All right, you're welcome back again. This time we want to look at a non-parametric test. So far, we have been looking at a parametric test in different from different angles, but we ended that with a maneuver. But this time we want to continue the course by looking at the other side, at the counterpart of the parametric test, which is a non-parametric test. For each single parametric test, we have also non-parametric test for them in case the assumption is violated. So one can easily switch over to non-parametric test. So the first one we want to look at today is called Wilcoxon assigned rank single test. This particular test is the one sample that is a test that is non-parametric alternative to one sample t-test. If you remember last time we did one sample t-test, otherwise called student test, and so on. So this particular one is what that replaces when the data cannot be assumed to be normally distributed. If you are not able to make data distributed, then it means that you have to switch over to this particular test called Wilcoxon signed rank single test. So we are going to be using the same data we have used before, which is mice, but just a little modification to the data set so that we can be able to use it properly here. So how do we define this? It is used to determine whether the median, because non-parametric test for single sign t-test so far is based on ranking, all right, not on mean like or previous parametric test is based on ranking, which is median. All right, it uses median, not mean. The other ones use mean, like t-test, peer test, unpair test, ANOVA, and the rest. So they use, but this one is based on median. All right, it uses median to rank. So that's what we are doing. So it is used to determine whether the median, now not no more the mean now, of the sample is equal to a non-standard value, or we are otherwise called theoretical value. So we may have a particular number of value that we want to look at. Maybe you have, like for the last time we look at 25 gram, okay, for the weight of a particular mouse, or average weight of mice, we call it 25 gram. So we want to check the test against that weight if it is significantly correct. All right, that is what we want to do. So if there is no any theoretical value, which we call reference value given, the reference value will become 0. So we have to test against 0. So if you have not checked, you have not, watched the previous video on that single test, you can just go and watch it so that you can understand clearly what I'm talking about. So that have been clearly defined and discussed there. So here we create an sample data set containing the weight of 35 mice. So we just run this. So we just set a seed. Then we say we create a variable called mice. We create a data frame. Now we call the name of each mice called m underscore 1, 2, 3, 4 like that. Okay. So this one is 1 to m underscore 1 to 35. Then we have the weight of each of the mouse is assigned. So we have the weight. So we use rnum to round off to 1 decimal place. So we generate the weight. All right. So now we can just even let's glimpse the data set and see what is inside. All right. And now we have a name, we have weight, the number of row 35, columns 2. All right, so that is what we have here. M underscore 1, M underscore 2. So this mouse 1, mouse 2, and to 35, and each of them has its own weight. All right, so we can check the box plot first and see how they look like. This is the box plot. And we have some outlier actually. You can see outlier, that one can be removed. Okay, that one can be removed. Let's log it. Let's say if you log it, Would that remove the outlier for us? Let me see. Open bracket, log. Let's see. No, it doesn't remove all the outlier, but some remove some. All right, so let's just remove the log. Okay. All right. So now let's look at the Q plot also, and how it look like. Look at the Q plot. You can see some outlier outside here. From here down, you can see okay, but we have 1, 2, 3, 4, and I think this also have 3, 4. So 1, 2, 3, 4. So these are uh, the outliers we have. You can check the outlier actually to know the number. You just dollar how to here. Okay, I've shown that before. If you remember, I showed us how to get that the outliers. Just run this line. You can see the outlier. How many? 1, 2, 3, 4, 5, 6. I mean that should be 1, 2, 3, 4, 5. 5 outliers. 5. So we have 5 outliers. So those are the outliers we have. So you can do something about it if you want. That one shouldn't be a problem. That have been covered so far. So the sample size seems to be large enough. At least we have 35 observations. However, we need to check whether the data pass the test for normal distribution. So we run the Shapiro on it. Okay, Shapiro test on it, and then we have a mice. We pass our mice on it. So we just run this line of code. You can see it's highly significant. So which means that the Shapiro failed. Okay, Shapiro failed. As you can see that the data failed normal distribution test. So we use non-parametric test. All right, so let's have a search question as usual. We want to know if the median weight of the mice differs from 25 grams. So this becomes our theoretical value or reference value. Okay. All right, so that's our MU. So now from this question, we can create our hypothesis now. Let's say null hypothesis says the median weight of the mice is 25 grams. That is what we hypothesize. All right. Now, but we want to test against it. All right, whether it is true or not. Alternative say the median weight of the mice is not 25 grams. So let's we have to run our one sample Wilcoxon test now. So let's just create a variable. We can just assign it to this, or you can just remove this. Just run it straight, right? Just run it straight. So we don't need to assign it. So we just pass our we run Wilcoxon.test, then we pass our weight inside, which our weight control variable here. Then our mu equals 25. We're testing against 25. So we run this line. So giving us 1 here. So don't worry about the 1. So we have some ties here. Don't worry about that. So 0.01014. This is significant. Okay. Yeah, alternative hypothesis true location is not equal to 25. That's what it's telling us, right? So we have to reject null hypothesis now, as they say it's equal to 25, right? We can also use maybe want to use some piping method. All right, we could report this as follow: the p-value of the test is 0.014, which is less than the significant value level alpha 0.05. We can reject the null hypothesis and conclude that the average weight of the mice is significantly different from the 5. Or we can say the median weight. Let's say the median weight. The median weight of the mice is significantly different from 25 grams. Right. So the way we did for the first T test, we can also do the same here. If you want to test whether the median weight of the mice is less than or greater than, let's say one tail test, one tail, you can also do the same thing here. Just pass our data here. Just say alternative equals to less for less than, for greater than, just another is equal to greater. So the same thing applicable here. So just run the same thing here. So that it seems there's not much difference between the two of them. So it's running. We have 0.007, which is significant. All right. Don't mind the 1 here. Okay. So that is that. So if the data are not normally distributed, it is recommended that you use normal parametric test, which is one sample Wilcoxon random test. So that is what. So we have just concluded with this. So this is just to show you the alternative way to do to perform your test if you are not meeting the t-test assumptions for parametric tests. So thank you so much for listening. If you have not subscribed, you can do that to see more of the videos on this channel. I'll see you in the next class. Thank you.